Hdlc, which stands for High Level Data Link Control. It is a bit-oriented protocol for communication or point-to-point and multi-point links. The topics in this section which we are going to discuss are configuration and transfer mode, the frames used in this, and the control fields which are used in the above frames. The configuration and transfer modes. The Hdlc provides two common transfer modes that can be used in different configurations. First is the normal response mode and second is the asynchronous balanced mode. In the normal response mode, the station configuration is unbalanced. There is one primary station and multiple secondary stations. A primary station can send the command and secondary stations can only respond, as shown in the figure. In asynchronous balanced mode, the configuration is balanced. The link is point to point and each station can function as a primary and a secondary. This is the common mode of communication for today's communication world. And under the Hdlc frames, there are three types of frames which are supported by Hdlc. These are: first is the I frame, second is S frame, and third one is the U frame. I stands for information frame, S for supervisory frames, and U for unnumbered frames. Each type of frame serves as an envelope for the transmission of different type of messages. The I frames, these are used to transfer user data and control the information relating to the user data. And S frames are used only to transport control information. U frames are reserved for the system management. Carried by U frames is intended for managing the link itself. So the Hdlc frames I, S and U frames are shown in the diagram. Each frame in Hdlc may contain up to 6 fields: a beginning flag field, an address field, a control field, an information field, a frame check sequence, that is FCS field, and an ending flag field. The fields which are used in the frames are: number one is the flag field. This field is an 8-bit sequence with the bit pattern 0, 1, 1, 1, 1, 1, 1, 0 that identifies both the beginning and the end of a frame and serves as a synchronization pattern for the receiver. Second field is the address field. It contains the address of the secondary station. If the primary station created the frame, it contains two addresses. If a secondary creates the address, it contains a from address. The third field is the control field. This field is a wide segment of the frame used for the flow and error control. The fourth field is the information field. This field contains the user's data from the network layer or the management information. Its length varies from one network to another. The last field is FCS field. The FCS is Hdlc error detection field, which stands for frame check sequence. Now the control fields which were used in the above frames as shown in the figure respectively for I frame, S frame and U frame. The control field determines the type of frame and defines its functionality as shown in the figure. The control field for the I frame. The I frames are designed to carry user data from the network layer. They can include flow and error control information. Defines the type. If the first field of the control field is 0, this means the frame is an I frame. Next 3 bits called NS define the sequence number of the frame. Bit called NR correspond to the acknowledgement number when piggybacking is used. The field PF means poll when frame is sent by a primary station to the secondary. It means final when the frame is sent by secondary to a primary. The control field for the S frames are shown in the figure. The supervisory frames are used for flow and error control whenever piggybacking is either impossible or inappropriate. If the first 2 bits of the control field is 1, 0, this means the frame is an S frame. The last 3 bits called NR corresponds to the acknowledgement number or the negative acknowledgement number depending on the type of the 2 bits called code is used to define the type of S frame itself. With 2 bits, we can have four types of S frame as described below. First combination is 00, which is used for receiver ready, that is RR. If the value of the core subfield is 00, it is an RR S frame. This kind of frame acknowledges the receipt of a safe and sound frame. In this case, NR field defines the acknowledgement number. Second combination is 10, that is receiver not ready, RNR. If the value of the core subfield is 10, it is RNR S frame. It announces that the receiver is not ready. The value of NR is acknowledgement in this particular case. The third combination is for reject, that is REJ. If the value of the core subfield is 01, then it is a REJ, that is reject S frame. RK frame, that is negative acknowledgement frame. The value of NR is negative acknowledgement number in this particular combination. And the fourth 11, this is for selective reject, SREJ. If the value of the core subfield is 11, it is an SREJ S frame. The value of NR is negative acknowledgement number for this particular combination. The control field for the U frame. The unnumbered frames are used to exchange session management and control information between the connected devices. U frame ports are divided into two sections, a 2-bit prefix before P by F bit and 3-bit suffix after P by F bit. So these two segments, 5 bits, can be used to create up to 32 different types of U frames as shown in the figure by the yellow color. And these are the combinations for this 5-bit code. Respective, we can take some examples, like if we are having the code 00001, then the command will be SNRM, the set normal response mode. And if the value of the code is 11011, then the command will be SNRME, which means the set normal response mode extended. And so on. These are the different combinations used for the U frame in the code frame. Introduction for the Hdlc, which is used as a data link layer as a protocol for communication. So thank you.